ecosystems despite their low nutrient inputs. And nitrogen is hereby of special interest because it limits the reef growth and has very low values. As for nitrate, they are ranging between 0.3 to 1 micromole per liter, and for ammonia from 0 to 0.4 micromole per liter. Therefore, the reef organisms have to have the ability to efficiently retain nutrients, new nutrients that enter the system, and to recycle old ones, or nutrients that are already in the system. So why are sponges so important in the nitrogen cycling of reef? First of all, they have a large population size. They are second to corals in most reefs, and in some reefs of the Caribbean, they are even the most abundant taxa. Moreover, they have the capacity to filter large volumes of water. They have reported filtration rates of up to 100,000 times their own volume per day. And another factor is that they have really high retention efficiencies, ranging between 58 and 99%. And on top of this, they have dense microbial communities like ammonia oxidizers, for example. And Corridor was the first one who reported really high flux rates of dissolved inorganic nitrogen and showed that they were 10 times higher than other marine benthic systems, like, for example, coral reef sediments. And my research question I posed myself was, are sponges helping corals in terms of food supply? And my first hypothesis is that sponges influence the DIN speciation in the water column and regenerate in these ways large quantities of nitrogen for the reef. And to examine this, I wanted to quantify the contribution of the spongy aspect to the nitrogen cycling by measuring changes in dissolved inorganic nitrogen during incubations in the laboratory and in situ at the Radisson Bay. And furthermore, I wanted to investigate if the spongy aspect is capable of nitrification, and therefore I looked if there occurred an accumulation of nitrate during the incubations or in water exiting the osculus of the sponge. My other hypothesis was that sponges influence the well-being of corals by introducing them to a new food source they were not able to exploit to a greater extent. And to find this out, I want to observe if corals are using the waste material of the feeding activity by the sponges, and therefore I wanted to compare the nutrient uptake if corals are alone in their incubations and if corals are together with sponges. Like, are there any differences and what kind of differences? And moreover, I want to measure the photosynthetic efficiency and the maximum rate of photosynthesis of corals alone and with sponges together. So I had two kinds of experiments. First, my incubation experiments. I did this with corals of the genus Fungia, and I incubated them alone. Then in the second part of my experiments, I incubated sponges alone, and in the third part, I incubated both together. And the second of my experiments where I measured in situ water, sponges inhold and exhold at the Radisson Bay. So first for my experiment, I had to collect the sponges in the reef, and I cut them and I tied them with cable ties to acrylic plates, and then I left them at the reef for recovery for approximately 1 month or 3 weeks, dependent at how good they were healing. And the Fungia corals, I collected them at Racha, and the collection was very easy because they all represent one polyp. You can just put them in a bag. And after the collection of the species, I maintained them in a flow-through system. And the corals I fed once a week with no bee larvae. and bought the sponges. Before I used them for the experiments, I looked like if the surface was healed. When they were freshly cut, they looked like this. And I took care that in the lab that everything was healed and you could see no signs of necrosis or something like this. And in my incubation experiments, I measured the changes in dissolved organic carbon, in total organic carbon, in dissolved oxygen, and in dissolved inorganic nutrients like nitrate and nitrate, and ammonia, and the concentration of cyanobacteria. And I incubated them over 5 hours, and I had sampling in the wall at time 0, after 30 minutes, after 1 hour, after 3 hours, and then after 5 hours when the incubation ended. And here you can see the first set of experiments when the fungia polyps are alone. I had glass aquaria, and they had a volume of 40 liters. And inside there were the small plastic aquaria, and one wall of them was replaced by a perforated plate. Maybe you can't see it so good here on the picture. And on the other side, I put an aquaria pump there. And this pump ensured a laminar flow then through the perforated plate over the coral. And I had as well always a temperature sensor inside. And I took care that the temperature didn't exceed 30 degrees. And on top of them, these are frozen water bottles, and they are in Ziplocs, which were before rinsed with hydrochloric acid to ensure or to regulate the temperature. And I had 6 replicates. First I put them just in artificial seawater, which I created with drinking water and red sea salt. And look what were the changes in the water column. And in the other 6 corals, I put in artificial seawater. And shortly before the incubation started, I added ammonia and nitrate to a final concentration of 30 micromole per liter and 100 milliliter of cyanobacteria I cultivated before. Before I put the corals in the basin, I measured the PI curves and after the incubation as well. And here you can see the differences of the control. This was the PI curve before the incubation started and this after the incubation. Here you can see the mean of the electron transport rate. And you can see that corals after the incubation show the lower electron transport rate compared to corals before. And this is contrary to corals where nutrients were added. There you can see that both corals are almost the same. But like to say something about the maximum rate of photosynthesis and the photosynthetic efficiency, I have to analyze it with a special software back in Germany then. For the corals, I have no results about the nutrients because it's very difficult to analyze them since the fungia polyps the mucus a lot, and this influences the nutrient measurements a lot, and I have to think about how to analyze it properly. And the second part of the experiments was the sponge alone, so I had the same chamber and everything, just that a sponge piece was inside. And I had again 6 times sponges in just artificial seawater and 6 times sponges where I added nutrients and cyanobacteria. And here you can see the changes in nutrients and the difference between the control and the treatment. And here are the control changes. They are measured in microgram per gram dry weight of the sponge. And you can see that there are almost no changes or very small changes in nitrate and ammonia. And when you look at the treatment, there you can see that there are really big changes and they accumulated a lot of ammonia. And to make it clear, I have here the changes in nitrate compared to control and treatment. Here are the control changes. And this curve shows the treatment changes, and there you can see that there is really a production of nitrate. And the ammonia values were a little bit strange because they were really strongly fluctuating, but there was not a real production, like they consumed a lot and then they produced again. And then the third part of the experiments, I incubated sponges and corals together. As well, I had six replicates for just artificial seawater and 6 replicates for artificial seawater with nutrients and cyanobacteria. But like this time to measure, I measured not only changes in the water column, but I tried to measure water which is released by the oscula as well. Like to see what changes did the sponge do to the water column. And here I have the PI curves. So there you can see this time at the control when the sponge was present that the electron transport rate of the coral wasn't lower after the incubation. It stayed almost the same. And again, when there were nutrients added and the sponge was present, the electron transport rate was higher after the incubation than before. And now I want to compare like the PI curves of the corals when I incubated them alone and when I incubated them with the sponge together. And you can see when after the incubation, when the coral was incubated alone, it's slightly lower, the PI curve. But like it's just a trend that it could be that they feel better with sponges than in the control because the sponges release nutrients they can use for their feeding activity. Yeah, and as you can see, the treatment after the incubation, the PI curve stayed the same, independent if the sponge was there or not when nutrients were added. And yeah, for the changes in nutrients, I still have to analyze all the nutrient values. Yeah, my second part of my experiments were in situ experiments at a radisson reef. And therefore, I took simultaneous samples of water close to the sponge and water at the oscula. Therefore, I used a syringe and went with the tip very close to the oscula and tried to very slowly take up water. Yeah. And there I have to analyze them all as well, still in Germany. Yeah, so my friend.